Vector projections. Let vector A be x1, y1 and vector B be x2, y2 such that vector A is not parallel to vector B. The projection of vector A onto vector B is the shadow that vector A leaves on vector B. And the formula is the projection of vector A on vector B is equal to the dot product of vector A and vector B over the dot product of vector B with itself multiplied by vector B, which is equal to the magnitude of vector A multiplied by cos theta, where theta is the angle between vectors A and B, the non-reflex angle that is, over the magnitude of vector B multiplied by x2, y2, which is vector B in component form. Let's have a look at the proof of the formula for the projection of one vector onto another. So let vector OQ be position vector x1, y1 and vector OP be position vector x2, y2. And those two vectors are shown on the Cartesian plane here. So there's OQ, there's OP. Now point Q has coordinates x1, y1, so that's this point here, and point P has coordinates x2, y2, which is this point there. Now vector OR, so that's this vector here from here to there, represents the projection of vector OP onto vector OQ in the direction of vector OQ. So this is the shadow of OP onto OQ, which is vector OR. And you can think of vector OR as a scaled version of vector OQ in the ratio, the magnitude of vector OR over the magnitude of vector OQ. Now the x-coordinate of point R is equal to x1, x2 plus y1, y2 over x1 squared plus y1 squared. So that's the dot product of OP and OQ over the dot product of OQ and OQ multiplied by the x-coordinate of point Q, or the x-component of vector OQ. And that's equal to the magnitude of vector OP multiplied by the magnitude of vector OQ multiplied by cos theta over magnitude of vector OQ multiplied by the magnitude of vector OQ multiplied by x1. And of course, the two OQs here cancel. And we end up with the magnitude of vector OP multiplied by cos theta over the magnitude of vector OQ multiplied by x1. Now, in a similar way, the y-coordinate of R, which is equivalent to the y-component of vector OR, is found in a similar way. Hence, the projection of vector OP on vector OQ is in fact vector OR, and that's equal to the magnitude of OP multiplied by cos theta over the magnitude of vector OQ multiplied by vector OQ.